Hello, my name is Amanda Pennington, and we are going to be going over Module 4 in exam. Right here. Okay, so our first question asked, question 1 says, pattern blocks are a popular and versatile manipulative that is used successfully in many elementary schools. The 4 shapes below are included in every set. You've got a hexagon, trapezoid, and triangle, and rhombus. It says, write 4 sets of fractions having 3 sets in each set. Let each pattern block be the base unit for a set of fractions, and so a fraction to relate each of the other shapes to the base. So first we are starting with the hexagon. And so when we break these up, all the shapes up, we're going to read them, but they have to be equally proportioned with all the shapes that we're using. So we know that a hexagon can be broken up into 2 trapezoids. So that will give us a 1/2 fraction. And then we know that we can use 6 equally sized triangles to get 1 hexagon. So that gives us 1/6. Next, we know that we can take 3 rhombuses and put them into a hexagon equally, and that gives us 1/3. A hexagon can be divided equally using different shapes. The first hexagon has 1/2 of a fraction because a trapezoid can be used 2 times to make a hexagon. Next, you can have 6 equal triangles to make a hexagon, giving 1/6. The last hexagon can be shown as 1/3 because 1/3 or 3 rhombuses can fit into the hexagon. Next, we're going to go on to a trapezoid. Alrighty, so we have a whole trapezoid, and we can break those down into 3 triangles, and we can shade those in at different times. We can have 2/3 and 1/3 for the trapezoid. A trapezoid shape can be equally divided using triangles. 3 triangles can fit inside a trapezoid, giving the denominator of 3. You can have 2/3 of a trapezoid, also 1/3 of the trapezoid, giving a remaining equal shaped triangle. Okay, now we're moving on to a rhombus. So with the rhombus, we can make it into smaller rhombuses that can fit in there equally. So we know that 1/2 can be divided into a rhombus. We know we can get 3 rhombuses into 1 big rhombus. So that gives us the 2/3 and 1/3. The rhombus can be equally divided into other rhombuses. 1/2 is equal divided with 2. And then we can divide the rhombus into 3 pieces, receiving 1/3 of the pieces together and then 2/3 of it, giving the 2 shaded parts. Next, we're going to be talking about triangles. So with the triangle, you can only break triangles down really into other triangles, especially with this type of triangle. So what we're going to do is we have 4 triangles and 1 single triangle, and we can shade that in, giving 1/4. Next, we're going to do the same thing we did with the first one, but for each small triangle, we're going to apply its method. So now, instead of 4 triangles, we have 16. And so for that one block, that 1/4 will become now 4/16. And then you're going to do the same thing to those, break each small triangle down into 4, giving us a total of 48 triangles. And 16 of them will be shaded. Triangles can be broken down into more equal triangles. 1/4 can be seen in the first triangle, leaving behind 3 equal triangles. If we break down each triangle again, we can use 4/16 because one triangle from 1/4 can make 4 equal smaller triangles for that one. Then we can use 16 and 48 because we can equally break down every triangle again. Here is question 2. A man bought a length of rope at the hardware store. He used 1/3 of the rope to make a bow painter for the canoe and then used 1/4 of the remaining piece to tie up a roll of carpet. He now has 36 feet of rope left, but was the length of the rope he had originally purchased. And so we know that it was broken down into 3 portions. We have used for the painter, used for the carpet, and then 36 feet left over. The 3 parts of the rope represent 36 feet. The part of each part of the length that was used was 12 feet long. So 36 times 2 equals 72 feet of rope. And that is going to be how you solve the problem. And this is our explanation. The 3 parts of the rope represent 36 feet. Since we are running the 36 feet, each part would become 12 feet long. 36 divided by 3 parts equals 12. So 36 times 2 equals 72 feet of rope, and the man bought originally. Next is question 3. So this wants us to use an addition of fractions with a number line and a model of fraction strips. So first we're going to solve the fraction. We have 1/3 and we're going to add 1/2 to it. So since those do not have the same common denominator, we're going to multiply those by each other. And so we're going to do 1/3 times 2. And whatever we do to the bottom, we got to do to the top too. So 1 times 2 equals 2, and 3 times 2 equals 6, giving us 2/6. Then we're going to do the same thing to 1/2. 1/2 times 3 to the bottom and the top. So 1 times 3 equals 3, and 2 times 3 equals 6, giving us 3/6. So 2 plus 3, 6 equals 5/6. And so on the number line, you can kind of see the different colors I use. We're going to move the numerator spaces on the number line, since all of the denominators here are 6. So we're going to move 1, 2 in yellow for 2, 6, and then we're going to move the 3 from the 3, 6 from where the 2 left off, 1, 2, and 3, landing on 5, 6. Since the denominators from the fractions now match the number line diagram, we will take the numerators and add these one at a time, which is what we did. And here's called a fraction strip model. And what that is this just breaks down the denominator and the shaded parts are the numerator. And it's just going to fall down and let us see visually what that is. So we have 2, 6, the 2 pieces shaded in of the 6, and then we have 3 pieces shaded in of the 6. I did this the first way so we can visually see how the 2 can bring down and equal to 5 6s. So we have 1, 2, 3, 4, 5 out of 6, 5, 6. That is the fraction total. Now we're going to go over 3b. We're going to add 1/2 and 3/4 together. So like before, we're going to do multiplying by the denominators of each other to the top and bottom. So 1/2 times 4 and 4. So 1 times 4 equals 4, and 2 times 4 equals 8. Then we have 3/4 times 2. 3 times 2 equals 6, and 4 times 2 equals 8. That gives us 4 8 and 6 8, giving us 10 8ths. And we're going to just come back to that 10 8ths later. So on the number line, as before, we're going to take the numerators and move those at a time. So first we had 4 8ths, so we're going to go 1, 2, 3, 4. Land on the 4 8ths, and then we're going to move the 6 8ths that we got from the second one. And we're going to go 5, 6, 7, 8, 9, 10, landing on the 10 8ths. Now we're going to look at our fraction strip. So we made the fraction strips the denominator number, which is the 8. So we have 4 8ths and 6 8ths. So when we bring those down together, we see that we don't have enough for one fraction strip model of 8 to fill it, because we have 10 8ths. So that means we have a remainder of 2. So we're going to go ahead and fill in another fraction strip, giving us the 10 8ths that we need. Next, we're going to solve 3/4 minus 1/3. So we're going to do common denominators method. So 3 over 4 times 3. So 3 times 3 equals 9, and 4 times 3 equals 12. Then we have 1 times 1/3 times 4, and that gives 1 times 4 equals 4, and 3 times 4 equals 12. So now we're going to minus it. We're going to take the 3/4 since it was the first number in the equation, which is now 9/12, and minus it by 4/12. And that will give us 5/12. So using a number line to show this, we are going to start out using the 9/12, since that's the first part of the equation. And we're going to go backwards to the left because we're subtracting the 4 spaces for the 4/12. So we're going to go 1, 2, 3, 4, and land on 5/12. Next, we're going to look at the fraction strip model. So we know that the boxes are 12 since it's our denominator. And the shaded pieces are 9 and 4. So 9 minus 4 equals 5/12. Here's another one. 3/4 minus 3/6. So we're going to get our common denominator. So 3/4 times 6 equals 18/24. And 3/6 times 4 equals 12/24. So 18/24 minus 12/24 equals 6/24. So with the number line diagram, we're going to start at 18/24. And we're going to go back the numerator of the 12 spaces of 12. So we're going to go, and this diagram is created in twos. So we're going to go back 2, 4, 6, 8, 10, 12, and land on 6/24. And so here's our fraction strip model. The boxes are 24. So 18 minus 12 gives us the 6 red boxes in the middle that follow down. Okay, next we're going to be using number lines and circle pie diagrams. So what this means is, for the first one, we have 3 times 1/5. And what that's saying is we're going to have 3 equal 1/5 each that we're going to multiply by. So we're taking 1/5 3 times. So this is going to be 3 times 1 equals 3/5. So we have 1/5 colored on the pie chart 3 different times. So we have 1, 2, 3. And then when we add those 3 separate 1/5 together, we get 3 out of 5 colored in the circled pie diagram. Now we're going to do that on the number line. So the number line is made out of fifths. So we have 1/5, 2/5, all the way up to 11/5. And so we're going to take the 1/5 and add that 3 times. So 1/5, 2/5, and 3/5 is where we're going to land on. Next, we have 3 times 2/4. Okay, so we colored in 2 portions of the 4 of the whole pieces of the pie. So 2/4 plus 2/4 plus 2/4 is what we're looking at. We know that if we add 2 of the 2/4 together, that gives us 4/4, which will equal 1 whole pie, with the remainder of 2/4 or 1/2 left, giving us a total of 1 plus 1/2 equals 1.5. And on the number line, we're just going to move the 1/2 3 times. So 1/2, we're going to land on add another half, and we're going to add it to get a whole 1, and add another half, and we're going to get 1.5. Next, we have 5 times 5/8. So that means we're going to have 5/8 5 times. So we colored 5 pieces of the 8 pieces of pie each time. And that's going to give us 25/8. So when we add those pieces together, we are getting 3 whole pieces of 8 pieces of pie with a remainder of 1. The 5 and 5 times 5/8 equals 25/8 means we need 5 fraction circles of 5/8. Then adding them together, 25/8, making it 3 circles and 1/8 left over 3. So the total will be 3 and 1/8 or 25/8. And as before, we're just going to have the common denominators, and we're going to add them not by 2 this time, but by 5s. So we're going to add 5/8 plus 5/8 plus 5/8 plus 5/8 plus 5/8 and get 25/8 as our total that we landed on. And so with the equation -5 times 5/8, it's the same thing, besides we're adding this negative sign here. So we have our 5 5/8 that will equal into 3 1/8. And since it started out with a -5 times 5/8, that number now changes from positive to a negative. So -25/8 or -3 1/8. And so that becomes a big deal when we use a number line, because we know if we have a negative, we're going to the left of the 0. So The number line is the same. We have 8, and we're going by 5s. But see, we're starting at the 0, and we're going to the left. -5 eighths, -10 eighths, -15 eighths, -20 eighths, and -25 eighths is where we landed on. So that's very important to pay attention to that symbol, the negative. Next, we have a square that we need to figure out the pieces of each area, what the area is of each piece. Well, starting with this, we see all these dotted lines, and so we want to make them equally proportioned. That way we can figure it out. So we do this by triangles. So we know that each area we can have a denominator of 16 because we can fit 16 equal squares, or triangles, my bad, triangles into that square. But we're still going to keep the area that we were in at the beginning of the black right here, those lines with the colors. So we know area A has 4 equal triangles. And since there's 16 equal triangles, that's going to be our denominator, 16. And the 4 of A is going to be our numerator, so 4/16. And we can break that down into 1/4. Now let's look at B. Area B also has 4 triangles. So we know that is going to be 4/16 or 1/4. Then we're going to look at C. C only has 2 triangles. So that's going to become 2/16. But when we break that down, it becomes 1/8. Next, we're going to look at D. D is all alone. It has 1 equal triangle. So that's going to become 1/16. Number E. Let's look at E. E has 2, which is 2/16, and breaks down to 1/8. F has 1, so it's 1/16. And G has 2. It looks like a rhombus, but it can be broken down into 2 equal triangles, giving us 2/16 or 1/8. We learned that 7 tanagram pieces make up the unit square. To get a common denominator, the pieces need to be equally proportioned. We can get 16 congruent triangles to fit into the unit square. We are still going to keep the outlines of the original pieces, using them to find the area. We are going to add the triangles in every original piece and use that number as a denominator with the 16 in the numerators. Then we have a recipe. The recipe below is for making 16 cookies. How many of each ingredient do we need to make 12 cookies? So we have 1/3 cup butter, 3 ounces unsweetened chocolate, 3/4 cups of sugar, 1 1/2 teaspoon of vanilla, 2 eggs, and 2/3 cups of flour. So first we're going to look at that. 1/3 cup of butter. Since we need to cut down, we're looking at 16. So 16 can be 4/4. But we need to make 12, which is 3/4, and that's what we're going to multiply by. So 3/4 times 1/3. So we do 3/4 times 3 equals 3/12 or 1/4 cup of butter. And so that's going to be the new ingredient measurement we're going to use. So then we have 3/4 of 3 ounces. So 3/4 times 3, that gives us 3 times 3/4, which is equal to 9/4 or 2 1/4. Since we're using measurements, we're going to have to go with that mixed number. So 2 ounces and 1/4 of unsweetened chocolate. Then we have 3/4 of 3/4 of sugar. So 3/4 times 3/4 equals 9/16 cups of sugar. Next, we have the vanilla. So we need to take 3/4 of 1 1/2. So 3/4 times 1 times 1/2, because we're going to break it down. So we know anything times 1 is itself. So we're going to X that out and do 3 times 4 times 1/4. And that gives us 3/8 teaspoon vanilla. Next, we have 3/4 of 2 eggs. So 3/4 times 2. So 3 times 2/4 equals 6/4 or 3/12. Since we need a mixed number, we're going to have 1 1/2 eggs. Next, we're going to have 3/4 of 2/3 cup of flour. So 3/4 times 2/3 equals 6/12 or 1 or a 1/2 cup of flour. And that's going to be the new ingredients. Since originally the recipe is for 16 cookies, which can be 4/4, 12 cookies is 3/4. Taking 3/4 and multiplying each ingredient, you will receive the new amount needed to make the 12 cookies. Following through every ingredient, receiving a fraction. Some fractions will be converted to a mixed fraction for the ingredient recipe. So the new recipe for 12 cookies will be 1/4 cup of butter, 2 1/4 ounces of unsweetened chocolate, 9/16 cups of sugar, 3/8 teaspoon vanilla, 1 1/2 egg, and 1/2 cup of flour. And so that concludes our module written exam, and I hope you have a very blessed day. Thank you.